All right. Well, it's 11 o'clock. Let's get rolling.
Okay. Welcome everybody. Dan, what number is this? Is this our 10th show or ninth?
This is our 9th show.
Episode number 9. Awesome. So today we're going to follow the theme of tech talk and talk about some of our technology, both hardware use and analytic use and control use. We're going to talk about control point technology and how to design with it and how to add it to an existing system and some of the benefits that you'll get by adding it to your system. So with that, Dan, why don't you take us from the top?
Absolutely. So we're going to look. So control points it's kind of a different concept. So I do want to take a moment and explain at a high level what a control point is and what it can do for you. So in its simplest form, a control point is a location to collect data. So the data that we have available that we can collect out in the field is flow data, but now we can also collect pressure data. So we know we have a pretty good idea of what we can do with flow data because it's been around for years, but pressure data is something new, and I think we're going to have a whole other Tech Talk episode to explore some of the things we can do with pressure. It's also a location for control. So we're talking about valve control and opening and closing a valve to do things with our irrigation system. So data and control are the two things that we're getting out of control point. Goes anywhere on the hydraulic system. And then we've got lots of programmable options with that data. So because we have a high flow level, doesn't necessarily mean that something's going to happen, but we can decide what's going to happen. Do we want to get an alert? Do we want to cause a chain reaction? Do we want to open a different valve? Those are different things we can do with the control point. So that's just kind of at the highest level what a control point can do.
Yeah, I might just jump in here too and just remind everyone, we've hit on this a couple times over the last couple weeks, that part of the reason we use 2-wire is to electrically turn solenoids on. The other use case is to collect data from devices in the field. And so following on that theme of collecting the data, adding these data points to the system, i.e. flow and pressure, allow us to gain more control of the system. And so by adding that valve control, we can not only read the data coming in from those devices, but then we can decide how we want to use that data to control different points of the system. And I think before we jump further, it's important to compare traditional technology, if you want to call it that, where we had these points, but it's only at the beginning of a system, right? So historically, you would have a master valve and flow sensor only at the start. And so what we're going to be talking about is taking that concept and moving it down anywhere on the hydraulic system. So I just want to point that out before we get too far.
Good. I think that's a good concept that we want to stress, and in moving it down, but also having multiples. So not just one. So, when I started 35 years ago, that flow sensor master valve was always at the beginning of the system if you had it.
When you started 35 years ago, it was still irrigation ditches.
Okay. I'll give you that. So let's talk about why and where we might want to collect data and have control on our system. So we might want to do the why might be for flow resolution, to get some visibility on how flow is moving at different points across our system. We might want to do it to isolate some of our piping structure. So that this is going to lead to what I'm going to call submains, isolating sections of main lines or isolating sections of our hydraulic structure. We might do it to collect pressure data and then react to that pressure data. We might do it for leak detection. So we'll look at each of those 4 different cases in a moment. And then where this might go in is, it could go in a single water source system. It could go on with a multiple water source system, or systems that have branching hydraulics that are a little more complex where the main line changes sizes. So Chris, the picture on the left in that valve box, can you tell us a little bit about where that's from?
Yeah, that's a control point, 2-inch, that was installed at a county courthouse in Utah. It was actually the first control point installed after we introduced it as a product.
Nice.
But you can see there on the left, you've got the master valve. And then right up against the master valve is the pressure transducer. And then downstream from that, at the right side of the valve box is the flow sensor. And in between, you've got the decoders that are mounted on the plate that are strapped to the pipe. So Andy, you've got a control point there with you. Hold it up and you can see that's in a 1-inch size, but essentially that's what's installed in that jumbo valve box.
Yep. So again, we've got our flow sensor and then the pressure transducer, and then you can add a master valve of your choice, and all of the corresponding decoders are potted together in that in this pot right here, and then all you're left with is your one wire connection that will either go directly to the controller if it's conventional, or right on your 2-wire path.
Mm-hmm. So Andy, this other picture we've got on the right doesn't look like, it looks like a little more complex system, but we've also got a control point set up here. But what can you tell us about that one?
Yeah, so what's interesting about this is this was an existing park system. I think there was maybe 12 athletic fields at this complex, and there was an existing Watertronics pump station. So you can see the Watertronics pressure gauge there. And then there's actually 2 transducers. The one that has the orange connector is the existing Watertronics pressure transducer. And then the client added the baseline pressure transducer to that same setup so that the controller has visibility of the pressure as well. And at this particular site, there was multiple water sources that they were prioritizing, one coming out of a pond, one coming out of a well. And so they were able to retrofit in the pressure transducers to capture that data coming out.
Yeah, you make an excellent point. Being able to get that data at the controller rather than just having the pump station itself separated and isolated from the control system is awesome.
Yeah, and on some of these sites, what happens is only one control can be the brain of the system. So what's happening is historically you had a pump station with some controls and an irrigation system with some controls, but they weren't really able to work together in harmony. And so what we're moving towards now is letting the baseline controller operate the system, and then the pump reacts to the demand that the controller is asking for.
Mm-hmm.
Nice.
The VFD. Yep. Brilliant.
Okay. So these are fitting on a couple of different types of systems, and it's nice to know there's lots of options on how to make this fit. So you just showed us the piece of hardware. So control point can be a piece of hardware. So just kind of reiterate, we've got the flow sensor, the pressure bicoder, the master valve bicoder, and the pressure transducer, all assembled like this in the factory, right? So this is what you would, if you purchase this control point PFS part number, this is exactly what you would get. All these components assembled at the factory, glued, spliced, one single wire output. What you add your own master valve, and then the pipe diameters upstream and downstream of the flow sensor are appropriate for whatever size flow sensor those are. So it'll look just like this. You'd add your own master valve into the assembly. Mm-hmm. So it can be a piece of hardware, but a control point is also a technology. And what's nice about it being a technology is it allows you to use some of your own hardware or to use just portions of hardware. So you might have a master valve and a flow sensor as a control point. You might have a hydrometer, which is a master valve and a flow sensor combined, as a control point. You might have a pressure transducer or just a single component, and that's a control point. So that's the technology concept. But in real world, right, here's a couple of installations that you were involved in, Andy, where they have actually has a couple of installations. What have we got on the one on the left?
Yeah, so the one on the left has, think of it like 2 water sources, I believe, and this was a large growing operation. I believe the one on the left has chemical in it, let's say fertilizer, I can't recall exactly, and the one on the right does not. And so they can control when they want to apply water, the fertilizer water versus the plain water. And then what's interesting about the picture on the right, which I thought is a really unique application, is they put a little manual ball valve
That's so nice.
onto the pressure gauge and transducer, so they can isolate it off, remove it, repair it, etc., very easily. So I just wanted to point that out because it was a unique application and really a great idea.
So essentially, what they did with the image on the left is they have a master valve, they have a pressure component, and they have a flow component. They're just separated, so it's not one assembly. But it's all in one location, and it fits with what they're trying to do on their site.
Mm-hmm.
So this, as a technology, it's really how we're addressing these components and how we deal with them. But a control point's also an enhancement of a controller. So if we look at the enhancement of the base station 3200, in addition to the zones and the programs, the water sources, and the main lines, we now have 8 different control points that enhance the capabilities to bring data or allow control for the base station 3200. So if I have 8 control points and up to 3 devices in each control point, that's another 24 devices to collect data or to manage my system. And it really can fine tune how that controller operates and how you can configure it.
Mm-hmm. Yeah, and it's good to point out too that there's a lot of existing 3200 controllers out in the wild that have been installed over the last 10 to 15 years. And this technology didn't exist before maybe about a year ago or so, year and a half ago. And you can update any of these older 3200 controllers so long as the hardware is compatible, and you can add control points. And so if you have an existing system that may have 50 to 150 or even hundreds of zones, and you have a complicated piping structure, you can add control points retroactively and either attach them to the 2-wire path, or you can communicate back to the controller with some wireless configuration. But you can by all means add what we're talking about today to any existing system.
Nice. Okay. I think it's time to look at our project that we had sketched out for us. So, hey, by the way, I think this is the coolest design board, this Miro board. I think it's a wonderful SketchUp illustration thing. So thanks for discovering this.
Yeah.
On this system, we've got a lot going on here. We've got a lot of hydraulics laid out. So let's take a look at a couple of things. I'm gonna zoom in. Well, let's describe what we've got. We've got a single water source, a 6-inch main line that runs through. The main line sizes down to a 4-inch, also sizes down to a 2-inch, and sizes down to a 3-inch. And then I've got this tank set up here. So we're going to look at a control point for just a single water source. So if we zoom in a little bit here we've got a 6-inch water source, and that's water source 1, and it's off of some other 6-inch line that we don't have any control off of it. And we run to a single 6-inch control point. So in that control point, we've got a master valve, a pressure component, and a flow component. So, and that master valve opens when it needs to and feeds the 6-inch main line, and closes when it needs to based off of our input. That's about as simple as a control point gets. What's mainly the biggest difference on this one compared to traditional master valve and flow sensor placement is it's still at the beginning of the system, but we've added the pressure component. So that's probably the biggest single difference on this example, where we're still leaving it back at the beginning of the system. So 1 water source, 1 control point. Well, let's look a little bit more complex and with a second water source. So we've got this 6-inch water source supplying our 6-inch main line, but up here on the roof, we've got a roof terrace, and there's a tank or a cistern, and we want to use that cistern to irrigate this zone up on the roof terrace. And we want to make that the first choice that we use when we pull water for that roof terrace, and the roof terrace only. So what we've done is added control point 6 up here with, it may have a master valve, and it has to have at least a master valve and a flow sensor, and it may or may not have a pressure component in there. It really depends on what we're after. In this case, we can have control point 6 open to feed the roof terrace and not have control point 1 open. But here's like the cool thing is, if the cistern's empty, we need to have when we have some sort of indication that the cistern's empty, control point 6 won't open, and it instead will feed from control point 1 and backfeed through the 6-inch main, through the 3-inch main to feed the roof terrace.
Yep, and that leads into perhaps a discussion we can have for another future Tech Talk Tuesday about using multiple water sources.
Right.
3200 controller does it amazingly well, and it really comes down to this control point technology and utilizing it for multiple water sources.
Right. So to that point, right, we do have to have a whole nother show about that, because a base station 3200 can handle 8 different water sources and can switch between 8 of them. And we're only showing 2. So we can handle a second water source. So that would be a great reason to use a control point. We could also use it for isolating sections of the hydraulic structure. So let's look at some submains. So if we come out on this far section, I've got the 6-inch, it turns to a 4-inch, and then we tee off of that. We've got a 2-inch feeding this far reaches of this main line. Control point 5 isolates this section of 2-inch main line. So control point 5 has to open in order for that 2-inch main line to get water. The way this would work in practice is control point 5 and control point 1 or control point 2 would have to open in order to get water out to this line. So this is now we're really getting to moving the control point away from the beginning of the system and putting multiple control points out there.
Yeah, and I think that it's probably relatable to think about that control point 5 as a replacement or an addition to an isolation valve. So oftentimes on these big complex piping structures, there'll be an isolation valve placed there so that if that portion of the main line either needs to be serviced or has a problem, it can be isolated off without turning the whole system off. And one way to think about what we're doing is either replacing or adding in addition the ability to control it in an automatic fashion. Instead of sending someone from the crew out there to close that isolation valve, we can do it electrically with the controller.
Well, you could do it in a much more timely manner as well, right? Because you could do it. It could happen in the middle of the night, where that manual ball valve or isolation valve is going to happen with your interaction. So let's talk about a break on those submains. We'll come over to control point 3 in this 3-inch main line. Well, if we had a break on this section, control point 3 might be able to better see that flow. So a 6-inch main line has a very high flow capacity, right? We could carry a lot of water through a 6-inch main line, and a 3-inch main line can't carry nearly as much. So what we can do is we can set the flow limit for control point 3 at a much tighter threshold of essentially what a 3-inch should carry. Because if we set that limit at control point 3 to what the 6-inch line could carry, that it would never shut off. So this gives us an ability to fine tune our flow for each branch of the main line and dial it in.
And then again, isolate just that section of the pipe and not turn the entire system off at the, quote unquote master valve, but turn it off at the control point.
Right. Right. And the big reason that people, designers size pipe, right, is to save cost. And it's not really a pressure thing. They don't need they don't need 6-inch pipe all the way through. But this allows them to still have their cake and eat it too, to get both. Leak detection is another one that we've talked about. So we're going to come back to the beginning of our system and zoom in a little bit here. So in leak detection, we're going to talk about those varying flow rates. So 6-inch pipe, tremendous amount of water. A 2-inch pipe, a lot less that can fit through here. So we want to be able to have to find low flow leaks that might be running when our system is in idle state. So middle of the day, water shouldn't be running. Well, if we have a 10-gallon a minute leak running during the middle of the day, or someone left a hose bib or a quick coupler open and it's just running all day, well, that's 8, 10, 12 hours that it's going to run. It could go undetected. And the reason it could go undetected is if we're running through our 6-inch master valve pressure transducer flow sensor, that 6-inch flow sensor isn't going to see 10 gallons a minute. Now, Chris and Andy, you looked up the flow rate on that when you said that 45 gallons a minute was the lowest that most 6-inch flow sensors could see, right?
Mm-hmm. Yep.
So 10 GPM is going to slide right under that 45 GPM lower limit. So we won't, it'll be invisible. So in this scenario, we can do a bypass with maybe a ball valve and another master valve pressure transducer flow sensor, and then loop that back in. And if we had the 6-inch as normally closed and would only open when we wanted it to, and the 1.5 inch as normally open, the main line's always pressurized, and that 10 gallons a minute would have to go through that 1.5 inch flow sensor. Now, the 1.5 inch flow sensor does have that resolution to get down to 5 and 10 gallons a minute. So it would see 10 gallons a minute, and then it could react. Now, maybe it's going to shut down, maybe it's going to alert you, but you have the ability to decide what it's going to do.
Mm-hmm.
Have you, Andy, have you had a chance to do leak detection in the field with this yet?
I haven't done leak detection in this scenario. We have had some projects that with a similar setup, but the design intent was to utilize that smaller flow sensor when only very small zones are running. So if you have going back to this drip zone on the roof, if it is not pulling from the sensor and it's 8 gallons a minute and it's running all by itself, then it'll go through control point 2 and use the 1.5 inch flow sensor so that we get that flow resolution instead of using the 6-inch sensor. So in these sort of control point grouping scenarios, that's where I personally have had experience. I know a couple of the other baseline RSMs out in the West have had more experience with the leak detection. I think it's a fantastic idea and a great place to position the product for sure.
And the actual site that this hydraulic structure is modeled off of, with that control point 1, control point 2 setup in that same configuration, they did discover that they've got a 17 gallon per minute leak on that system that they're aware of, but they haven't taken the time or the resources to go and try to find it because it hasn't come to surface anywhere. It's just going straight to groundwater, but they do know that it is leaking at that rate.
Right. Wow. And I think another point that we want to make is I said the 6-inch was normally closed and the 1.5 inch was normally open. They could be whatever configuration that makes sense for your site, right? They could be both normally closed. You could have them. It's very easy to program which is normally open, which is normally closed. Really depends on what you want to do with the hydraulics on your site.
Yeah, that bypass scenario, it's nothing new. It's been in existence for quite some time, but having the ability to have them both as normally closed rather than having to have one as normally open is new to this control point technology.
One other one that I want to look at is pressure. So on these far reaches of that system, about where you've got your cursor, Andy, we've got a low pressure issue, and that's the furthest our main line is from our water source, from that 6-inch water source. So if they have some pressure issues out here, and they may not know exactly why they have pressure issues, so they have the ability to add a control point, and in this case, they may not want to do a flow sensor. They may want just a master valve and a pressure component. Or maybe they just want the pressure component, but they're able to add a pressure component at control point 5 or back over here where that PR is. They could do it in either location. Really depends on how long that section of mainline is, and they can find out what real-time pressure is doing out in the field. React.
Yeah. I mean, maybe the pressure's only dropping at certain times of the day. And I think Chris mentioned this a couple weeks ago that a 10% drop in pressure can have a 40% effect on the water distribution. And so this is the far extremity of the piping structure. And typically this is where sometimes pressure issues come to be, especially if the piping wasn't sized correctly and you're noticing that perhaps the distribution is not correct. You can go ahead and add a pressure transducer and start tracking the data there.
For my years of being in the field, there's a lot of what's hidden under the ground? I don't know. We're assuming it's a 6-inch main line all the way through, but somehow you're routing through, 50 feet of 2-inch main line. And every time you run that one section of the system, you get a dramatic drop in dynamic pressure. Those are really hard to diagnose and really hard to find, even though your starting pressure is good. This can help you do some of that sleuthing and figure that out. You can figure out what was running at what time and what's going on. So
let's see, Dan, just to keep track of time here, we got about 5 minutes left. So if you don't have any other major talking points, maybe we should open it up for Q&A.
Let's do that.
I've got a question already brought to us by Antonio or Antonia. Both control point 1 and 2 are normally closed. How can a leak be detected when the irrigation is off?
If control point 1 and control point 2 were both normally closed, how would you do leak detection? You couldn't, because you wouldn't know if water was running through it. You would have to have one of them normally open. Absolutely right.
Yep, exactly. So one would need to be normally open for that leak detection capability. Yep.
Yeah, this leak detection concept I really love. I mean, the idea of anything 2-inch and larger, if you had a 1-inch bypass, the resolution you're going to have on that is going to be is so much better than what you might normally have with your larger sensor.
Mm-hmm.
Yep. And then Don's got a question about the number of control points. So the 3200 platform supports 8 control points. And again, that consists of 8 master valves, 8 flow sensors, and 8 pressure transducers. So that would be a total of 24 possible data points, but it's 8 control points.
Right. Excellent.
All right. Very good. That's all we've got in questions.
Okay. Let me stop sharing. There was a concept that we were talking about earlier was and this is a little bit nerdy, was the concept of a master valve, right? And a master valve, master valves have been around as long as all of us have been in the industry. And a master valve is, Andy said, it's a master, right? It controls all the other valves because there's one master valve. Well, maybe we need to be in control points. We need to stop thinking of them as a master valve, because it's really a remote control valve, or as an automatic, as Andy kind of alluded to, an automatic isolation valve that's in multiple locations, because you can't have 8 masters. You could have.
Right. And if we have, typically they're in a lateral assignment versus a vertical integration, like sub-metering. And so there are other platforms that can support more than one quote unquote master valve, but it's really designed to be in that like horizontal setup where they're side by side, but they're not downstream of each other. And I think that the best way to think about a control point would be to think about places where you have manual isolation valves, or where you would design with a manual isolation valve, and you're going to either add or replace that with control point technology.
Right. I like that.
Yeah. So let's see what's going on next week, Dan.
Next week, we're going to talk about managing difficult water windows in a couple.
Wait, that's a trick question.
Oh, it was. Got me. Got me. Okay. Next week is it's a day off. It's a vacation day.
Right. We decided that Tuesday next week is really the Monday of the work week, because it's the first day back after Memorial Day holiday. And so we're going to take that off because we know you guys are all busy. And so next week will be we're going to skip it and rejoin the following week. So when we do that, what's the topic, Dan?
Then it will be managing difficult water windows.
Awesome.
There you go. And that will be on June 2nd. Just
excellent. Thank you.
Clarify and mark everybody's calendar.
Yep. Beautiful. Difficult water windows. Water windows seem to be basic in concept. You can water or not water, but there's a lot that goes into it, and a lot we even talked about today that can play a big effect on how to manage those difficult water windows.
Does that mean we get to talk about working outside of the start time?
Oh, gosh.
Wow. We just went nerdy over the cliff.
Awesome.
We might.
Look forward to it. Excited.
Yeah. Awesome. Well, we hit it pretty much right on 1:30. So thank you, everyone, for joining us. And we look forward to seeing you back in 2 weeks.
Yeah, we appreciate your support at Tech Talk Tuesday. Have a good week.
Cheers.